Hi everyone! Welcome to my YouTube channel where you can find videos that will make math more fun and easy for you to become winner in numbers, winner in life. So in this video, I'm going to present to you how to find the greatest common factor or GCF of two or more numbers. So this topic is also a very important topic that we need to understand. But of course, before going to our discussions, let me shout out first to the first one who comment with the correct answers on the exercises given on the video on how to differentiate prime numbers from composite numbers. So this time, we have a new one. And he is no other than Clarence CJ Rasul. So again, CJ, thank you very much for supporting my YouTube channel. I hope that you will continue supporting my channel by watching all my videos as well as my future videos. For those who have not commented yet or have not suggested any topic for my future videos, you may do so by following these simple steps. So if you notice, you cannot comment on the comment section on every video that I upload. It's because my YouTube channel is intended for kids. So automatically, the YouTube disable the comment sections. But you can still comment or suggest topics for my future videos by clicking this show more icon here for you to be prompted with the links for my Facebook page as well as my Twitter account. Once you click this link for my Facebook page or the link for my Twitter account, you will be prompted with my Twitter account and my Facebook page, ROWEL CARPIO Math Tutorial. Now, going back to our discussions on how to find the greatest common factor or GCF of two or more numbers, we will have this illustration first. In this illustration, we have to find the greatest common factor of 4 and 6. First, we have to identify into how many different groups we can divide each number. Okay, let's start with 4. We can group 4 into one group with all the 4 units in the group. Aside from one group, we can also group 4 into 2 equal groups with 2 units per group. And finally, we can also group 4 into 4 groups with 1 unit in each group. Now let's go to 6. We can also group 6 into one group with all the 6 units in the group. We can also group 6 into 2 equal groups with 3 units per group. We can also group 6 into 3 groups with 2 units per group. And finally, we can also group 6 into 6 groups with 1 unit per group. Looking at the number of groups for 4 and 6, we can see that both 4 and 6 can be grouped equally into one group. Both 4 and 6 also can be grouped equally into 2 groups. Now, based on this illustration, we can now answer these questions. Based on our illustrations earlier, we said that 4 can only be grouped equally into one group, into 2 equal groups, or into 4 equal groups, while 6 can be grouped equally into one group, into 2 equal groups, into 3 equal groups, or 6 equal groups. We can see here 4 and 6 can be grouped equally into one group or into 2 groups. So the number of groups that is common, we have only 1 and 2 equal groups. Now, since 2 is bigger than 1, so therefore the greatest number of groups common to both 4 and 6 is 2. So these 1, 2, and 4 are the different ways that we can group 4. So in other words, 1, 2, and 4 are factors of 4, while 1, 2, 3, and 6 are also factors of 6. So among the factors of 4 and 6, only 1 and 2 are common factors of 4 and 6. Now, between 1 and 2, 2 is bigger than 1. So therefore, the greatest common factor of 4 and 6 is 2. We cannot use all the time our illustrations to identify or to find the greatest common factor. So we have to use other methods. So I will be discussing 3 methods for us to use in finding the GCF of 2 or more numbers. So let us begin by using the first method, which is the listing method. We will be using the listing method for us to find the greatest common factor or GCF of 8 and 12. From the word alone, listing, we have to list down all factors of 8 and all factors of 12. So let us begin by identifying or listing down all factors of 8. When we said that factors, these are the numbers that can divide a given number equally. So we have to identify all numbers that we can use as divisors for 8. So we can start with 1, since we know that 1 is always a factor of any number. So 8 divided by 1 will give us 8. So in other words, 1 and 8 are factors of 8. Or we can do the other way using multiplication. 1 times 8 is equal to 8. So meaning to say that 1 and 8 are factors of 8. Aside from 1 and 8, we can also divide 8 by 2 to give us 4. So meaning to say that 2 and 4 are also factors of 8. Or we can multiply also 2 times 4 is equal to 8. So 2 and 4 are also factors of 8. So we have here now the factors of 8 because we cannot find any more other numbers that we can divide from 8 except these numbers given here. So meaning to say the factors of 8 are, we have 1, 2, 4, and 8. So let's go to 12. So 12 divided by 1 will give us 12. So or we have 1 times 12 is equal to 12. So 1 and 12 are factors of 12. Aside from 1 and 12, we can also divide 12 divided by 2 to give us 6. Or you have 2 times 6 will also give us 12. So 2 and 6 are also factors of 12. And finally, we have 12 divided by 3 to give us 4. Or we have 3 times 4 is equal to 12. So in other words, we have the following factors of 12. So we have 1, 2, 3, 4, 6, and 12. So let us identify now the factors that are common to 8 and 12. So we have here 1 is common. We have also 2 common, and also the 4 as common factor of 8 and 12. So let us write the common factors here. We have 1, 2, and 4. Among these factors that are common to 8 and 12, 4 is the biggest. So automatically, 4 is the greatest common factor of 8 and 12. Aside from the listing method, because the disadvantage of using the listing method is if we have bigger numbers. Why? We might miss out the factors of the given numbers, especially if the numbers are big enough for us to identify all the factors of the given number. So, aside from the listing method, we can also use this second method, which is the prime factorization method. So, in this method, we are going to identify the prime factorization of each number. When we write the prime factorization of a number, we simply express the number as a product of its prime factors. So, let's start with 6. So we can use the factor 3 method. In here, it is as if we are breaking the number into 2 factors. So we have to think of other than 1 and itself, what other pair of numbers that we can multiply to get 6. So we can have 2 times 3. So here it must be 12, not 6. Our prime factorization of 6, 2 times 3. Now let's have the 12. When we break 12 into 2 factors, we can use 2 times 6 or 3 times 4. So either of these pair of numbers we can use. So we can use 3 times 4. Now 3 is already a prime number, so we can just bring it down. But 4 is not yet a prime, so we can still use 2 times 2. So we have now our prime factorization for 12, 3 times 2 times 2, or we can also have 2 times 2 times 3, following the commutative property of multiplication, that when we change the position of the factors, it will not affect the product. Now, we are going to write here the prime factorization of 6, which is 3 times 2 or 2 times 3. For 12, you have 3 times 2 times 2. And then we are going to identify the factors or prime factors that are common. So we have here 3 common. So we will write it here 3. We have also 2 as common prime factor. So times 2. So this 2 is not anymore common because we don't have any more 2 here to pair with this 2 of 12. Our greatest common factor of 6 and 12 is the product of 3 and 2, which are the 2 common prime factors of 6 and 12. So we have here is equal to 6. So therefore, the greatest common factor of 6 and 12 is 6. What if we don't have a common prime factor? Okay, let's say we have here 5 and 12. So if we look at 5 and 12, we don't have a common prime factor for 5 and 12. So if we don't have a common prime factor, automatically 1 becomes the greatest common factor, because we know for a fact that 1 is a factor of any number. And finally, we will be using the third strategy. We call this as the continuous division method. So in this method, we continuously divide the given numbers using only prime divisors. So let us have this example. So this time we have now 3 numbers. So in using this continuous division method, we will be using the inverted division sign. And then the numbers that we are going to find, the GCF, will be our dividends. So we have here 8, 12, and 16. We have to find now a common prime divisor for 8, 12, and 16. If we will be using 3, we can only divide 3 to 12, but not for 8 and 16. But if we will use 2, we can use 2 to divide from 8, 12, and 16. Meaning to say that we will use 2 as our first common prime divisor. So 8 divided by 2 is equal to 4. 12 divided by 2 is 6. 16 divided by 2 is 8. We have now our new numbers, 4, 6, and 8. We have again to think of a prime number that we can divide from 4, 6, and 8. We can use 2 again as our common prime divisor. So 4 divided by 2 is 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. Now let us take a look at our new numbers, 2, 3, and 4. We cannot find anymore a common prime divisor for 2, 3, and 4 except 1. So meaning to say we have to stop. how are we going to identify now our greatest common factor? We are going to write down all common prime divisors that we have used. We used 2. We also used another 2. To get the GCF, we just simply multiply these numbers to give us 4. So therefore, the GCF of 8, 12, 16 is 4. The same way also, if we cannot find any other prime divisor to divide to our numbers, automatically 1 is our GCF. Let us have another example. This time, we have to identify the greatest common factor or GCF of 5, 6, and 10 using these 3 methods. So we will start using the listing method. So again, in the listing method, we have to identify factors of each number. So let's have 5. The factors of 5 are 1 and 5. So in other words, 5 is a prime number because it has only 2 factors, 1 and itself. 6, aside from 1 times 6, we can also use 2 times 3 or 2 and 3 as factors of 6. So therefore, the factors of 6 are 1, 2, 3, and 6. For 10, aside from 1 and 10, we can also use 2 and 5. So the factors of 10 are 1, 2, 5, and 10. So if we look at our factors for 5, 6, and 10, we only have 1 as the common factor of the 3 numbers because 2 is only common to both 6 and 10, while 5 is only common to 5 and 10. So therefore, the GCF is 1. Now let's use the prime factorization. So let's start with 5. Since 5 is already a prime number, so we will just bring it down as 5. So the prime factorization of 5 is 5. For 6, we have 2 times 3. So the prime factorization of 6 is 2 times 3. For 10, we have 2 times 5. If we look at our prime factorizations for 5, 6, and 10, we don't have a common prime factor because 2 is again common only to 6 and 10, while 5 is only common to 5 and 10. In other words, since we don't have a common prime factors, but we know that 1 is a factor of any number, so automatically our GCF is 1. Let's proceed to the continuous division method. So we will be using the inverted division sign, and we will put the numbers 5, 6, and 10 inside the symbol. Now we have to think of a prime number that we can use as divisor for 5, 6, and 10. If we are going to use 2, we can only use 2 as divisor for 6 and 10. If we are also going to use 5 as our divisor, as a common divisor, we can only use 5 to divide from 5 and 10. So in other words, we don't have any other number that we can use as common divisor for 5, 6, and 10. So in other words, we have to use 1. And then we have 5, 6, and 10. So automatically, our GCF is 1. So it is now your turn to answer the following exercises. So you are going to find the GCF or the greatest common factor of each set of numbers for number 1, 9 and 18. For number 2, 12, 20, and 24. So once you are done computing or finding the GCF of these given sets of numbers, you can use the tag hashtag GCF, then your correct answers, and then you may post your answers on my Facebook page or my Twitter account for you to get a chance of a free shout out on my next video. Thank you. I hope that you have learned and enjoyed watching this video. See you again on my next video. Thank you.